Welcome back, guys. In today's video, I'm going to be covering Sig Figs. So in this video, I'm going to be going over what makes something significant, and then we'll talk about the rules for addition and subtraction, multiplication, division. We'll talk about the log rules, and then we'll tackle some practice problems. So first off, what makes a digit significant? So we have to follow these four rules. So the first rule is that non-zeros are significant. So it's a pretty straightforward rule. Any number that is not zero, you're going to call that a significant figure. Rule number two, zeros between non-zeros are significant. So if you have the number 304, right, this zero is between two non-zeros. So this zero is significant, okay? So rule number two says that if you have that zero between two non-zeros, that is going to be a significant figure. Okay, zeros to the right of a decimal are significant. So if you have something like 25.0, this zero is significant, as well as this one and this one. Now, there is an exception here that I want to go over. So I start it. If you have something like 0.05, you're starting with a zero. And when you have a number that starts with 0 point and whatever's after, these are not going to be significant, okay? So these two zeros are not going to be significant. This number would only have one significant figure, okay? So the only time you're gonna see those zeros not be significant there is when you're starting with 0 point whatever. Now, if you had 0.050, these two, I should say, are significant, okay? So those are both significant because this zero is now following that significant figure after the decimal. These two would not be, okay? So these are not significant, but once you start with a significant digit, then zeros after that number, after a decimal point, would be significant, okay? So that's rule number three. And finally, rule number four says that zeros before the decimal at the end of a number are not significant. Okay, so if you have the number 350, right, no decimal point, okay, at the end of this number we have a zero. This is not significant. So this would only be 2 Sig Figs. Okay, so those are the rules for determining if something is significant or not, okay? So now, seeing these in calculations, if we have addition and subtraction, we need to follow a rule. So if we have an addition or a subtraction problem, we're going to keep the least number of sig figs after the decimal. So what does that mean? So if you have something like 5.343 plus 2.82, what we're going to say is this has two significant figures after the decimal. This has three. So in our answer, we can only have 2 sig figs after the decimal. Now when we do this out, we get 8.613 or 8.163, okay? Now, we can see that this has 2 sig figs after the decimal. We're not going to keep 3, we're going to keep 2, so we're going to make this 8.16, okay? Now, if we had 14.9896 minus 3.212, again, there's 4 after the decimal point here, 3 after the decimal point here, so we're going to keep 3 after the decimal point, and this is 11.7776. We're going to need to keep 3 after the decimal point, so we're going to do 11.77, and we're going to use this 6 to round this 7 up to 8. Okay, so this is going to be 11.778. Okay, so that's addition and subtraction. We're going to keep that least number of sig figs after the decimal. Multiplication and division, we're going to keep the least number of sig figs in total, okay? So if we have a multiplication problem, 25.0, that has 3 sig figs, right? This is after the decimal point, so it's significant. This has 5 sig figs. We're going to keep 3 total sig figs in our problem. Okay, so the answer to this is 3,039, which has 4 sig figs. So in order to get around that, what we're going to do is we're going to call this 3,040, right? We can use this 9 to round up. Okay, so we're going to call this 3,040. That's going to allow us to have 3 total sig figs, right? 1, 2, 3. The zeros between two non-zeros, so it's significant. this is not a significant zero, okay? We have 14.96 divided by 3.5. So this number has 4 sig figs. This number has 2 sig figs. So we're going to keep 2 sig figs in our answer. And if we do the math here, it's 4.274. Okay, so we need to keep 2 total sig figs. So we're going to call this 4 point, and we're going to round up this 7, right, is going to round this up to 3. So 4.3 will be our final answer. Okay, now one thing about logs, right, we're going to use this special rule for determining sig figs with logs, right? So if you're doing logs, right, if you're taking the log of something, or in chemistry we're going to take the negative log of something a lot of the time. So what we're going to do is we're going to say there are 2 total sig figs in the number we're taking the negative log of, okay? So we're going to find that number of sig figs in that number. So we found it, it's 2, right? These are not significant, right? We're starting with 0 point something, so these are not significant, okay? So once you found out how many sig figs are in that number, that's how many sig figs that we need after the decimal point in our final answer. So this comes out to 1.60205. Make sure I wrote that down right. 1.60205. Okay, so there's 2 sig figs in this number, meaning we need 2 total sig figs after the decimal point, so we're going to keep that 1.60. Okay, a tricky rule, but make sure you know how to do sig figs for logs. Now let's tackle these practice problems. Determine how many sig figs are in the following numbers. We have 4,036. These are all significant. The zeros between 2 non-zeros, so we have 4 sig figs. Let's go to 350,000, okay? There's no decimal point here, this is a comma. So zeros at the end of a number before a decimal point are not significant, right? That's rule number 4. So these are not significant. There's only 2 sig figs in this number. 0.0050. Now remember, these are not significant, right? 0.00, these are not significant figures. These 2 will be though. And remember, this 0 is significant, right? Because once you've reached that significant figure after a decimal point, zeros after that will be significant, okay? So this is 2 sig figs. And 25.00 will have 4 sig figs because these are significant, right? In that decimal point right there, those zeros after that decimal point will be significant, right? And if you're confused, remember, these are not significant because the 0 is here. These are significant because these are significant figures, okay? Now, let's calculate using the right number of sig figs, okay? So we have a multiplication problem with 3 steps. Now, one rule I like to follow, if you're doing multiplication, I should say, in division, you want to make sure you're not rounding early. So what I would do is I would multiply all 3 of these in my calculator, right? And then at the very end, what I would do is say, okay, I have 4 sig figs here, 3 sig figs here, and 4 sig figs here. I'm going to round that number that I get at the end to 3 sig figs. So if you're in a long multiplication problem or long division problem, right, don't keep rounding early for every step. When you get this out, when you do the math out for this one, you get 2,514. You get 2,514.11988. 11988. Okay? Now, we see that there are 3 sig figs. So this number needs to have 3 sig figs. So 2,514, right? With all these decimal points, we're going to get rid of this, okay? And what we're going to want to do with 2,514, right? We need to get that to 3 sig figs. So what we can do is call this 2,510, okay? That's going to allow us to have 3 sig figs. Now you could also put this in scientific notation, right? You could call this 2.51 times 10 to the third. And that would give us 1, 2, 3 with a place for that 0 to hang out in this number, okay? So 2.51 times 10 to the third. If you don't want to leave it in this, 2,510 form. Okay, so 2.51 has 3 sig figs. We're all set. Okay, this last one, and I put this in here just to show one exception. So the only time you should round early, I should say, is if you're switching from multiplication and division to subtraction and addition, or vice versa, right? So if I'm doing a problem like this, I don't want to round early. I'm going to get my answer in the calculator, find out how many sig figs I have at the end. However, in a very rare problem like this, it's not very often you have to do addition and subtraction and then do multiplication and division. It's not very often in chemistry that you're going to have to do that. However, if you do have a situation like this, what you want to do is you want to make sure you have the correct number of sig figs after the decimal point here, right? And then we're going to multiply. So when we do this out, we get 16.2578. 16.2578. Okay? Now, this has 4 sig figs after the decimal. This has 2 sig figs after the decimal, okay? Following subtraction rules, I want to make sure I have 2 sig figs after the decimal. So I'm going to round this to 16.26, right? This is a 7. We're going to round that up to 16.26. Now I'm going to multiply by 4.0. And now I have to follow multiplication and division rules, right? This has 2 sig figs. This has 4. Let's keep 2 sig figs. So this is 65.04. And we want to keep 2 sig figs. So I'm going to keep this as 65, right? You could do 65 or you could do 6.5 times 10 to the 1, right? And that would move the decimal point here if you want to keep it in scientific notation, okay? So we went over what makes something significant. We went over the rules and we did some practice. Hopefully you found this video helpful and make sure to check out more on the channel.